Okay, today we're talking about systems of equations and we're going to use something called elimination where we will literally eliminate one of our variables in order to solve it. So this is our final way to solve systems of equations. We're going to be doing this tomorrow as well, just looking at some harder examples tomorrow. So when we do elimination, we have a goal. So I'm going to write this down. Our goal is to have the same number but different signs. So I'm looking for the same number but different signs. And they need to have the same variable, and so they need to be like terms. But same number, different signs, that's our goal. As long as we have that, we can eliminate that term and just be left with one variable. So we'll see 8 examples of that today. So for number 1, I'm looking for the same number, different signs. So if I look at my y's, they both have a 6, and one's positive, one's negative, so different signs. So what we're going to do is we're going to add down. So 4x plus 3x is 7x. 6y minus 6y is 0, so they are eliminated. That's the goal. 32 plus 3 is 35. So we get x equals 5. Now once you get one variable, so x equals 5, you pick whichever equation you want to plug it into to get the next variable, so your y. So I'm just going to choose to pick the first equation, but again, you can pick whatever you want. So 4x plus 6y equals 32. So 4 times my x, which was 5, plus 6y equals 32. 4 times 5 is 20. Subtract 20 from both sides. You get 6y equals 12. So y equals 2. So your coordinate is 5, 2. Second example, again looking for same number but different signs. So my x's, they both have a 4 and they have different signs. So this is eliminated. 3y minus 5y is negative 2y. Negative 3 plus 5 is 2. So y equals negative 1. So once you get that, again, pick whichever equation you want. I'm going to choose the bottom one this time. So we had a positive x, so x minus 5 times your y value equals 5. So negative 5 times negative 1 is positive 5. Subtract 5 from both sides. Get x equals 0. So the answer is 0, negative 1. Okay, number 3, again looking for same number but different signs. If I look at my 3 x's, they have the same number but not different signs. So I'm going to use my y's. Now they're not lined up, so I'm going to line them up. So I'm going to rewrite the first equation, because that's what I do. And then when I write the second equation, I'm going to line up my like terms. So that was a negative 4y, so negative 4y. That is a positive 3x, so positive 3x equals 14. Okay, so now I can eliminate my y's. 4y minus 4y is 0, so that's gone. 3x plus 3x is 6x. 22 plus 14 is 36, so x equals 6. So from there, again, pick whichever equation you want to plug it into. You can even plug it into one of your new equations, doesn't matter. So I'm going to just pick the first one. So we have 4y plus 3 times my x, which was 6, equals 22. So 4y plus 3 times 6 is 18. Subtract 18 from both sides. Get 4y equals 4, so y equals 1. So our coordinate would be 6, 1. Okay, number 4, again looking for same number, different signs. So my x's have the same number and different signs. So I'm going to rewrite the first equation because I want to line my terms up. That was a negative 6y, a positive 3x, and a positive 18. 4y minus 6y is negative 2y. That's gone. 12 plus 18 is 30. So y equals negative 15. So again from there, just pick whichever equation you want. I'm just going to pick the first one. So 4 times, That was weird. 4 times my y, which is negative 15, minus 3x equals 12. 4 times negative 15 is positive 60. No, sorry, negative 60. Minus 3x equals 12. I'm going to add 60 to the other side to get negative 3x equals 72. When I divide by negative 3, I get negative 24. So your coordinate should be negative 24 and negative 15. Okay. Now the next four are going to be a little bit more difficult just because we will have the same number but not different signs. So there's an easy solution to that. Okay. So for number 5, I noticed my x's have the same number but they have the same sign. Not what I want. So a quick way to fix that is just pick one of the equations and change all the signs. So I'm going to leave the first equation alone, but I'm going to change all of my signs on my second equation. So 2x minus 2x is 0, gone. 5y minus 9y is negative 4y. 6 minus 22 is negative 16. So we get y equals 4. And again, pick whichever equation you want. So I'm going to pick the first one. We get 2x plus 5 times my y, which is 4, equals 6. 2x plus 20 equals 6. Subtract 20. 2x equals negative 14. So x equals negative 7. So your solution, negative 7, 4. Okay, number 6 has the same thing going on. My y's are the same, but they have the same sign as well. We don't want that. So a quick way to fix that is change all of your signs. So I'm going to rewrite the first problem and change all my signs for the second one. 5x minus 7x is negative 2x. That's gone. 7 minus 11 is negative 4. So x equals 2. Pick whichever equation you want to plug it into. I'm just going to pick the first one. So 5 times my 2 minus y equals 7. 10 minus y equals 7. Subtract 10 to get negative y equals negative 3. So y equals 3. So your solution is 2, 3. Okay, number 7, our x's are the same, but again, different signs, and they're not even lined up. So I'm going to rewrite the first equation. And when I rewrite the second equation, I'm going to move my terms around so that they're lined up, but I'm also changing my signs. So my 8x was positive, now it's negative. My 7y was positive, now it's negative. And my 7 was positive, now it's negative. So my x's are gone. 3y minus 7y is negative 4y. 11 minus 7 is 4, so y equals negative 1. And then pick whichever equation you want to plug it into. I'm going to pick the first one again. So 8x plus 3 times your y equals 11. 8x, 3 times negative 1 is negative 3 equals 11. Add 3 to both sides to get 8x equals 14. So when we divide by 8, we're not going to get a pretty number. That's okay. So divide both sides by 8, and you get 14 over 8. So you can leave it like that. Your answer is 14 over 8, negative 1. So you can leave 14 over 8 how it is. You can reduce it. You can change it to a decimal. I don't care. But like I said, I'm perfectly fine with you leaving it. So if you want to leave it, leave it. Okay, next problem is like number 7. Our like terms are not lined up, and our y's have the same number, the same sign. So I'm going to rewrite the first equation. And I'm going to line up my variables, but change my signs. So 2x was positive, now it's negative. My 3y was negative, now it's positive. 11 was positive, now it's negative. 6x minus 2x is 4x. This is gone. 27 minus 11 is 16, so x equals 4. pick whichever equation you want. So again, I'm just going to pick the first one. 6 times 4 minus 3y equals 27. 24 minus 3y equals 27. Subtract 24. Negative 3y equals 3. So y equals negative 1. So your solution for negative 1. Okay. So tomorrow we're going to be looking at similar questions, but they're not going to have the same number and sometimes not this different sign. So we're going to fix that. If you have any questions, please let me know.